Okay, so today's lesson is going to be on patterns and expressions. So our objective or content objective is going to be to identify and describe patterns. And the language objective is going to be to describe patterns with specific vocabulary, including constant, variable, numeric expression, and algebraic expression. So we're going to do that now, or we're going to start by defining some of those terms that I just listed. So on the left-hand side, let's write the word, and then we'll draw a line. On the right-hand side, we're going to write the definition. An example, so our first word is variable, and the definition is a symbol, usually a letter, that represents one or more numbers. So an example, or a couple examples you might be familiar with, you have x, or you could have something like n. So those are both examples of variables. The next term we're going to talk about is a numerical expression. Also, just as a side note, a constant, while I'm not going to define it in this table, is just a number that doesn't change. So it's sort of the opposite of a variable. So a variable, it can represent different numbers. A constant only represents the number that it is. So it's a number that's unchanging in an equation. So, sorry, back to numerical expression. So a numerical expression is a mathematical phrase that contains numbers and operations. So an example of that could be 2 times 3 plus 4. So that would be an example of a numerical expression. Next, we have an algebraic expression. So this term means a mathematical phrase that contains one or more variables. So an example of that could be 2x plus 1, or you could have something like 3n minus 2. Both of those are algebraic expressions because they contain both numbers and variables, or it just contains a variable, more specifically. All right, so now we're going to do an example problem. So the problem asks, how many toothpicks are in the 20th figure? So I'm going to draw them off to the side here. So our first one has 4. Our second one has 8, and our third one so make sure you're drawing those each as distinct lines. So it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And then this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So that leads us into our next thing. I'm going to do 2 column notes again and write what we're going to do here. So use a table, and I want us to look for a pattern that relates the figure number to the number of toothpicks. So we're going to start, I want to label our figure numbers. So that's figure 1, this is figure 2, this is figure 3, just for your reference. I'm going to write the table off on the side. So figure number will be our first column, which this is going to be our input. Then we're going to write our process here as we think, and then our number of toothpicks will go here, which is our output. So this patterns, our functions represent patterns, as do sequences. This is all sort of similar stuff to what you may have seen before, but really we're going to try to connect our inputs or our figure numbers, which we have figure 1, 2, and 3, and we're trying to figure out figure 20, and connect it to our outputs, which we know this has 4 toothpicks, this one has 8 toothpicks, and this one has 12 toothpicks. So now I'm trying to figure out what could I do to 1 to get 4 that could also do to 2 to get 8 and 3 to get 12. So if I think about it, I could add 3 to 4 or 3 to 1 to get 4, but if I add 3 to 2, I don't get 8, so that doesn't work. If I did 1 times 4, that might work. So I can reason through 1 times 4 gives me 4, 2 times 4 gives me 8, 3 times 4 gives me 12. So that seems to be a pattern that works. And if I think about this pattern here, I have 4 and then I get 4 more, so that's 2 times 4. And then I'm going to add 4 for each figure number. So if it's the 4th figure number, I'm going to have 16. The 5th, I would have 20. So on the 20th, we write in our pattern, we have 1 times 4, that gives me 4. 2 times 4, that gives me 8. 3 times 4, that gives me 12. So I'm multiplying numbers by 4, so here I would do 20 times 4, which would give me 80. So what I did here was I used the pattern to determine the 20th, or the number of toothpicks, in the 20th figure. So I just followed my own pattern. I realized multiplying worked because adding wasn't going to give me each time. And if I did a combination of multiplying and adding, I think it would be more complicated than just doing what I did. So I'm going to turn the page. The last part of this that I wanted to go over to, or 2 more parts, but I wanted to do the second part together because that has more to do with making algebraic expressions. So there we used numeric expressions to represent the pattern. Here we're going to try to use algebraic expressions. So what is an expression that describes the number of toothpicks in the nth, what's an n? Nth figure. So now our figures are going to be represented by, our figure number is going to be represented by n. So here I'm going to use the table again. I am going to use a table again, so I'll start by that. So I'll do figure number, which is still our input. Then I'm going to have our process column. and then the number of toothpicks, which is our output. So again, we've already connected our input to our output. We know that we're multiplying by 4. So here, in this case, the nth figure. So they're telling me I'm replacing n for my figure number. So I'm going to put n here. So I know n times 4 would give me my output, which I could write n times 4 or 4n. They're the same expression. So I used my pattern, going back to fill in what we were doing as we thought through this, to determine the algebraic expression. So n ended up being my variable for my input to provide me with my output. So the last thing I'm going to conclude is therefore. So those 3 dots, you'll see me use them every now and again in the notes. Therefore, the number of toothpicks is equal to 4 times n. All right, so we're going to do a quick check really, really fast. So I want you to copy and complete the table below. So I have an input, and I'm actually going to leave you your own process column now, so you can think through with that, and then the output. And we're going to have 1, 2, 3, 4, 5, and then I'm going to give you some space, and I want you to go up to n. Okay, so pause this. Oh, sorry, no, I'm going to give you the output, sorry. So 3, 4, 5, 6, and then I want you to figure out 5 and n. So those are your blanks you're filling out. Pause this, try this on your own. All right, I'm going to go over it now, so if you haven't done it, pause it. So here, I'm trying to figure out what I could do to these inputs to get these outputs. So if I have 1, I could multiply by 3 to get 3, but if I do 2 times 3, I get 6, not 4. So multiplying doesn't work. So I could do 1 plus 2, and that gives me 3. So that's 1. And then if I do 2 plus 2, that gives me 4. So right now adding 2 works. So plus 2. 1 plus 2 gives me 3. 2 plus 2 gives me 4. 3 plus 2 gives me 5. So that seems to be working. 4 plus 2 gives me 6. So it seems that we found our pattern. We're adding 2 to our input each time. So here I do 5 plus 2, and that would give me 7. And then if I go down to this, I know my input is n plus 2, which is the same as n plus 2 or 2 plus n, however you prefer to write it. So those are our notes for today. Make sure you write down any questions you have so we can go over them together in class.